In this lesson we are learning to solve equations in C. Now what does that actually mean? Well, if we go back to some basic solving equations that we would have done much earlier in school, we would have solved some equations like this: x plus 3 equals 7, and we would have solved it and got x equals 4. We may have then progressed to more difficult things like this: x squared equals 16. And now we notice that we've got a power of 2. So we would expect two values of x would make this true, and so sure enough we take the square root of both sides and we get x equals plus or minus 4. So we get two solutions, or two roots for this particular equation. Please note this equation could also have been written as x squared minus 16 equals 0. Would be an equivalent way of writing this equation, which we could have then factorized. It's a difference of two squares. X minus 4, x plus 4 equals 0. Therefore x minus 4 could be 0, or x plus 4 could be equal to 0. Therefore x equals 4, or from that case negative 4. We get the same answer either way. So in this example here, it was a linear equation, so we had one solution. In this question here, it was a quadratic equation. We had two solutions. Another quadratic equation could be something like this. We've seen a few times. X squared minus x minus 6 equals 0. We factorize it. X minus 3, x plus 2 equals 0. X equals 3 or negative 2. So that's how we've solved equations up until this point. Then recently, in our previous lessons, we've been looking at factorizing polynomials. So we might have had z cubed minus z squared minus z plus 10, and we've had to factorize that. And we would have gone through the lengthy process and ended up with 3 factors. What we're looking at now is, what if the question actually said solve z cubed minus z squared minus z plus 10 equals 0. See, as it is here, it's an expression. It's equal to, pz is equal to this. However, as soon as we take out the pz and we put in a value there, and the most convenient value and common is to put 0 in, is we now have an equation rather than just an expression. And so what we could do now is, our first step, if we were asked to solve this, our first step would actually be to factorize this bit. So in order to give us some notation, we'd let pz equal z cubed minus z squared plus z plus 10. We'd do all of that and we'd factorize it and get our 3 factors eventually. And then we'd say, therefore, these factors, according to the original thing, are equal to 0. And then it becomes a question like either this one, where we've got 2 factors multiplied together to give 0. Here we'd have 3 factors. Therefore, we'd get z equals all 3 different solutions. Okay, so solving these sorts of polynomials is just an extension from factorizing, but we do need to make sure that if we're factorizing like this, that it is equal to 0, because that's the basis. Because it's equal to 0, that's the basis that we say x minus 3 equals 0, therefore x equals 3. So that's an important point to note, and you will be able to trial some of those sorts of problems. However, what I want to look at now is, and we'll go on with this, what about a situation, and I'll give you a very, very simple example. Say we had z squared equals 1. Well, z squared equals 1, we can solve, take the square root of both sides, and we'd get z equals plus or minus 1. What if we had z to the 3, z cubed equals 1? Well, this is really a very simple polynomial. It's really z cubed minus 1 equals 0. Because it's a degree 3, it should really have 3 factors. And therefore 3 different solutions. 3 different solutions. Same with here. But if we look at any conventional maths that we've used up till now, we take the cube root of both sides, we get z equals 1. We only get one solution. What are the other 2 solutions? Negative 1 certainly isn't, because if you go negative 1 cubed, you don't get 1. So we've only got one solution. That means if z equals 1 is a solution, z minus 1 must be a factor. What are these other 2 factors? And a bit of a hint, they must have been complex conjugates, because these coefficients are all real, therefore the complex roots would occur in conjugate pairs. But what we'll head to in the next lesson is actually looking at how do we solve equations such as this. Or it doesn't have to be equal to 1, it could be something like z cubed equals 10, for example. We know there's 3 solutions to that. What are they? So that will be in our next lesson.